content credit goes to Lander. We haven't actually practiced this, but this is water treatment, and this is for definitely a higher level. Probably not even 7th or 8th grade. There's a lot of vocabulary in here. So this is really new. Like I said, I just got it yesterday. I think you just made it yesterday, right? Yeah. So this is going to be a higher level, but it's water treatment lesson.
What happened to old water treatment?
Huh?
We're still
This is the new one.
So we're always teaching.
Yeah, we're gonna I'm gonna have this like.
Water treatment shouldn't be scheduled for a class lower than 4th grade.
Yeah.
Sometimes it does happen, but it really shouldn't be ever happening for less than 4th grade.
Yeah. And so, like I said, this is definitely a higher level. There's probably words in here that you guys don't know because I learned them yesterday.
So where does water come from? Water is, we have what's called the water cycle, okay? So we kind of see it here. What we get is evaporation, condensation, and then it rains again and runs off. This goes into much more detail than I can probably explain. What's going on? Here's a river.
That's where we get our water.
The Truckee River.
Yeah.
I'm not putting anything together, let alone 2 and 2. But just keep going. That's the Truckee River, guys.
Alright, so there are 2 different types of sources of water. First we have groundwater, and that actually flows beneath the Earth's surface. And we can actually use pumps to get that out of the water. Some things about groundwater is that it's actually at risk for contamination. We'll talk about contamination later, but actually it has some natural filters, so it's kind of naturally treated in a sense.
The second source of water is surface water, which we can get we can actually transport it with just pipes. Again, we're going to need a pump to create the suction, but we can just use a system of pipes, which actually go under our roadways and our infrastructure, which a civil engineer designed to get them to where we want.
Alright, so here's, what's the significance behind this?
I just thought it was cool because it's Archimedes screw and there's water in
And
it,
there's water
and I just loved
validation,
it.
so this can be used in water treatment, and if they've had a simple machines lesson, elaborate on that because this is a real world application. Alright, so next we have different types of contamination. So this is all the bad stuff in our water. So it can include human or industrial waste. There can be leaking of underground storage tanks. Then also on the smaller scale we have bacteria, viruses, and protozoa. And then also salts and dirt, like earth. That's what earth stands for, I think. So dirt can actually get in our water. And we don't want to drink any of these, do we?
No. So how do we actually clean water? So there's all sorts of different methods on how to clean water, but I believe for today's purposes we're going to be focusing on filtration and purification. So what I mean by that is we use filters. We're going to talk about that in more detail. But we're going to first filter the water, get all the chunks, all the visible stuff out, and then we're going to purify it. That's generally through a process of chemical treatment. And we check the pH because for our water we want the pH to be at 7, which again we'll elaborate on later.
Alright, so this is a picture of Chalk Bluff, which is actually in Reno. It's a water treatment facility. That's just an overview. So first we have filtration, and that's basically getting all of the big stuff out of our water. So if we have dirt or rocks or dead fish, apparently, anything like that, it's actually going to filter those things out since we don't want that in there.
Coagulation and flocculation.
Like I said, this is a little advanced. This would be for like high schoolers or love that.
So sedimentation is, let's say I want to drink chocolate milk, and I'm like, more Ovaltine, please. So I put in some Ovaltine in my chocolate milk, and I mix it up, okay? So now I've got this delicious beverage, and I leave it on the counter, okay? Don't leave it out too long because I know it's going to spoil. But I leave it on the counter, come back to it later, after I was watching YouTube, Mel videos specifically. But basically, when those fine Ovaltine particles go down to the bottom of your glass, that is sedimentation. So to avoid sedimentation, I would take a spoon and I would mix it. But for these purposes, we actually want sedimentation to happen. So basically let the water sit, let all your chocolate milk stuff go to the bottom, and then pour it off the top. That's sedimentation in a nutshell.
Next we have clarification, and you can actually send the water through different filters of carbon and sand, and it removes the turbidity, which this would be high turbidity, so it's all foggy and muddy and stuff. And then over on the left side we have clear water, so that's what we want, and that's what clarification gets us.
Next we have disinfection, which is a form of chemical treatment to remove or deactivate microorganisms, okay? So things that get you sick. So bacteria is actually, there's good bacteria and bad bacteria, okay? So we have bacteria in our yogurt. If your yogurt says probiotic on it, sometimes make your tummy feel better if your tummy hurts. So sometimes we want bacteria, sometimes we don't. In our water, we do not.
Alright, and then next we have the chemical treatment, and the chemicals used in the chemical treatment would be synthesized by chemical engineers. And basically, this is going to help fix our pH, which we're going to talk about right after this, and it's going to make it less acidic or less basic, depending on what we desire. We just have to add the right chemicals.
So here's the pH scale. Anything from a 0 to a 6 is a what? Anything from an 8 to a 14 is a what? Base or an alkaline. Neutral is 7. Acidic or basic does not mean good or bad. Okay? If you look up here, you see 3 is grape juice, orange juice, soda. 4 is tomato juice. We drink those things, we consume these things, and they're okay. But in terms of water, we want a pH of 7. And sometimes you'll notice at your faucet, we can measure the pH there, and sometimes you get a 6 out, sometimes you get an 8 out of there, so it might be slightly acidic or slightly basic. And what happens, maybe they got it right at the actual plant, water treatment facility, but when they flow through those pipes, there's all sorts of stuff in the pipes. There might be a leak somewhere, there might be contaminants in the pipe itself, so it changes the pH on its way to you.
Yeah, and then we do our water treatment experiment. Should we go over that real quick?
Newbies, for water treatment, we have a bin, or like a jug sort of thing. Okay, so this jug has bark and wood chips in it, and it has a little screen in it. So what you do is, while someone's presenting this, someone else should be setting up the experiment. So basically you pour in vinegar into this wood chip bucket, okay, and then pour in water into that thing too. So it looks like nasty water, and you say, here's a sample of water, we just got it from the Truckee River. What's our first step? And it's filtration, so then you filter it into another bucket. Once that's filtered, you have the students letter them off, okay, so everyone gets an A, B, or a C, because the tubs have numbers on them, which is the second part. So call them up, have all the A's test the water the first time, and you should get an acid. You will get an acid, like a 3 or 4, something like that. And once you do that, you say, what's the next step? It's chemical treatment. So then you treat it, you pour in baking soda, things fizz, people like that. And then you have all the bees come up and test it. So once the bees have tested that, you're satisfied that your water is more or less neutral. You say, we're not going to actually use baking soda and vinegar to treat our water. There's actually chemicals synthesized by chemical engineers. After that, there's 3 tubs, okay? You set up these tubs, doesn't matter which is which. One's going to have baking soda, one's going to have vinegar, one's going to have just straight water. Corey is brave enough always to volunteer to drink the tub that comes out as slightly neutral. So he drinks it, so we kind of make like the mission to not kill Corey.
Yeah, make sure that you know what's going on there too, because one class got me to do it. I drank the baking soda. It does not taste good.
Yeah, so letter the kids off, make sure they know a letter, and then when they're dipping into the tub, make sure they know what tub they're dipping in. And and then I like to have the students sitting, or standing, excuse me, when they're telling you what pH they got, okay? Because if they're standing, they know they're supposed to remember. It's sort of like on their feet, the lights turn on.
Have we done anything about getting new pH tables?
Yes.
They're actually laminated. I believe.
Are they actually the right color?